Hi everybody, Tommy Clayton here, OpenSciEd middle school teacher and lesson writer. We're back at our unit Forces at a Distance 8.3 with lesson 10. So we're going to take some time to talk a little bit about how we got here, take a look at this lesson at a glance, highlight some key moments, and talk a little bit about some material management and tips and tricks. This lesson starts a new lesson set, and the lab can be a little bit tricky. And so there's some setup to this that's really going to help with what students are going to do in lesson 11. And so I learned a lot from doing this lesson. I'm excited to share some tips and tricks with you to help that lab go a little bit smoother, which will then help with what kids do in lesson 11. All right, so let's dig in. All right, so let's remind ourselves a little bit about how we got here. So in the last lesson, we really put it together and figured out a lot about how the speaker worked. We figured out how that magnet and coil can work together to make that speaker move back and forth. And so in this lesson, we're really wondering more about like what's up with the strength of the forces. We've seen some pretty crazy things, and we've seen some big speakers. And so we're wondering like, how does the distance affect the strength of those force pairs? Because we noticed that the speaker has a magnet and a coil that are super, super close together. So we're wondering more about that distance piece. So let's take a look at this lesson at a glance. This lesson is 3 days. It's an investigation lesson. It's going to take you about 25 minutes to set up, not super complicated. There is a hands-on investigation, and students do not need devices during this particular lesson. Okay, so there are really kind of like three chunks to this lesson, and each kind of happen within a particular day. So this first chunk on this first day, we're really going to like figure out what the variables are that we are going to change and what we're going to measure. Essentially, we're spending a good part of our time going back to the driving question board and planning out our investigation. Then on the second day, we're going to really carry out that investigation. And so we're going to take some time to collect the data and really see how the magnets can repel and attract and do some really careful measurement. And then on the third day, we are going to really analyze that data, interpret it, and make sense of it. So that's really where we're going to figure out that the force really gets really, really weak the further that the magnets are apart. And it's not linear. It has this really rapid sort of decline in that strength. So ultimately, what we're figuring out here is on the first day, we're figuring out our plan to carry out the investigation. The second day, we actually do it. And then the third day, we're putting it all together to figure out what it actually means. So let's take a look at some of the key moments in this lesson. So in part one of the lesson, we revisit the driving question board. We realize we have a lot of questions about the distance between them, about factors, about things that determine the strength of magnets. So we decide that we want to develop this investigation. And so we're going to co-design this investigation as a class. And so we're going to look at the tools that we have available. And so that's going to be a ruler, a set of magnets, a scale, some tape. And what we're going to do is identify that our independent variable is going to be the distance between the magnets. The dependent variable is going to be that force. So we're going to measure the weight or that push or that pull that happens. And then we're going to make sure that we're using the same magnets, that we're taping one down, and we're using the same measuring tools throughout. Okay. Real important that we take time to do this because you'll see how this sets up our plan for lesson 11. Okay, so we carry out the investigation, and so we're going to tape one magnet to the scale. We're going to zero out the scale, and then we're going to hold magnets at different distances away from it and take measurements. And then we're going to repeat that again, but we're going to have flipped the orientation. So if we started out with the magnets attracting, we're going to get those different measurements, and then we're going to flip it so that they repel and again get those measurements. This is going to take the kids a little bit of time, and you'll see why in a little bit. So in part 6, right, so after we've collected our data, we want to actually analyze and interpret that data. So we're going to graph it. We're going to use the I-squared strategy. So we're going to figure that out if it's something new to us to allow us to analyze and interpret the data. So you can see some sample data on your screen and a sample graph minus the axes labeled. Okay, so after we collect the data, we make sense of it, we have a discussion to sort of put things together. We wrap this lesson up by really thinking about like, well, we now know that distance really matters. The closer that magnets are, the stronger that those forces are. But we're like, what else, right? What else can we try or change that could affect those the strength of those forces between the magnets? So let's talk a little bit about some tips and tricks in this. So when students are conducting the investigation, the numbers are going to bounce around. You really want them to try to be as still as they can when they are holding that magnet above the other magnet. They're going to see the scale sort of fluctuate, and you're going to work with them to try to keep it as still as possible. And they're going to try to get sort of the average of what they're seeing. So let them practice a little bit and get a feel for that. You may even want to demo one example with them with an overhead camera, or if you can make a video of it. You're going to want to make sure that the students zero the scale out with the magnet on top. So you're going to have them tape down the magnet and then zero it out so that we're making sure that we're starting with a zero reading. We want to make sure that students are measuring the magnet that they're holding over it from eye level, so not looking above or below, so that they're super accurate. And real important, the scale needs to be set to ounces. Okay, that's going to be super important for when we're doing our graphing. So when the students are actually graphing the data, after they've collected the data, you can see some samples on your screen there. What we're going to have them do is actually multiply those measurements by 100. So it's going to help them to graph. They don't have to deal with all these different decimals. And it'll help them to really have a much cleaner graph, and it'll give them an easier time to set up their axes. The kids are going to be dealing with negative numbers, right? So when we set up the magnets so that they attract, it's actually going to lift the scale. We're going to get these negative numbers. And that can be a little bit confusing to students, right? That can help them to think that maybe there's two different relationships or that there's something going on there. So you may want to have them sort of fold the graph paper so that they can see that when they're actually on top of one another, the relationship between them is actually very, very similar. And you can have them also kind of look at the numbers and think about absolute value to help them see that the relationship is actually very, very similar, regardless of if it's attraction or repulsion. What we really just want them to see is that the further the magnets get away, the weaker they get, the weaker those forces are. Okay, so we have a new word we're going to earn in this lesson, which is to quantify, which is where we figure out that means to measure something with numbers, to be more exact. Depending on the level of math that your kids have been exposed to, we may introduce the words linear and nonlinear here, where we're introducing the relationship between distance and the strength of the magnets. But if your kids are not used to these words, or they're not sure, they're just being exposed to them, that's fine. They can still make sense of the relationship without those words. There is a poster that we are going to update. So that's our cause and effect tracker that we've been building all along. We're going to go and add a little more here about this new relationship that we discovered. All right, that's going to do it for us. I hope you found this useful. The way that students are measuring this force is going to be used again in lesson 11. So real important that we get a really good handle on this setup, that we have some practice with it, because we're going to use it again in lesson 11. We're going to use similar ideas in terms of planning our investigation and our data collection. So lesson 10 does a really good job of setting the stage for them to then do a little bit of investigation planning without all of the scaffolding. Come back and see us for lesson 11, and we'll see you next time.